Okay, we're going to have a wee look at quadratic graphs. Okay, so we've got some quadratic graphs here. These are our parabolas. We've had a wee look at what these look like before. We're going to study them more in depth now. Okay, so our basic parabola is of the form y equals kx squared. When it's of the form y equals kx squared, it always goes through the origin. It always goes through the centre point on your axis. As ever, can't get my pen to work. So it goes through this point here. When k is greater than 0, when it's a positive number, we say the parabola is happy. It makes a nice happy smiley face and gives a minimum turning point, which we spoke about before. When it's negative, it gives us this sad face and a maximum turning point. Okay. Looking at the first example then, for the parabola y equals kx squared, it passes through the point 212 and we want to find the value of k. Whenever we have a coordinate point, we have an x value and we have a y value. So y is 12, x is 2, so we just sub them into our equation and solve for k. 2 squared is 4, let's get 12 is 4k, so k must be 3. Second one, same idea again, we've got an x, we've got a y, that's going into y equals kx squared. By the picture, we are hoping we're going to get a negative value for k. Let's check, so subbing in my x, my y, so get minus 75 is k times 5 squared. 5 squared is 25, so 25k, dividing by the 25, get k is minus 3. Okay, let's look at a graph in a different form then. Okay, when it's written in completed square form, like x minus a all squared plus b, that gives us a minimum turning point at a, b, and an axis of symmetry of x equals a. Note the x coordinate is always the opposite sign of the number in the bracket. The y coordinate is the number outside the bracket and is exactly the same. So we want to sketch this graph then. So y equals x minus 2 all squared minus 3. That gives me the turning point of 2 minus 3, an axis of symmetry of x equals 2. It's going to cut the axis when x equals 0, so that's going to find where it cuts on my y-axis. When x is 0, y is 0, minus 2 all squared minus 3. Minus 0 minus 2 is minus 2, minus 2 squared is 4, 4 minus 3 is 1. So cut the axis at 0, 1. Should also note here, it's a positive x squared, so it's a minimum turning point, so it's a nice smiley happy face. So it's a turning point of 2 minus 3, so that's going to be about there. It's going to cross the axis at 1, so it's going to cross there, and it should be a nice smooth curve. There's x, there's y, and there's my graph. Y equals x minus 2 minus 3. We need to have important points marked on. We need to mark on our turning point. We need to mark on where it crosses the axis. Let's try the second one. I want to sketch x plus 3 plus 2. That gives me a turning point of minus 3, 2. Still a minimum turning point. It's positive x squared. It's going to cut the axis when x equals 0. So x equals 0. Y is 0. My equals 0 plus 3 all squared plus 2. 0 plus 3 is 3. 3 squared is 9. Add 2 is 11. So it's going to cross at 0, 11. So my turning point is minus 3, 2. It's somewhere here. And it's going to cross my y-axis here at 11. Make sure we have both turning point and where it crosses the axis marked on. Come on, page. Okay, let's see if we can do the opposite then. So given the graph, can we rewrite it as the equation? So here I've got turning point minus 2, 1. So that goes back into my equation. Remember the x coordinate, the bit in the bracket, always has the opposite sign. So that'd be x plus 2 all squared plus 1. The reason it has the opposite sign is we're looking for how we get to that turning point. So we go along negative 2 up 1. So I want to think what's going to make that bracket 0. So it needs to be the plus 2 because minus 2 plus 2 gets me back to the 0 because it's inside the bracket. Okay, the equation of the axis of symmetry then would be x equals, and it's always whatever the x coordinate of the turning point is. It would be x equals minus 2. Looking at this one, I've got turning point 4, 2. Let's get y equals x minus 4 all squared minus 2. Again, bit in the bracket, opposite sign, bit outside the bracket, same sign. My axis of symmetry is always x equals whatever my x coordinate of the turning point is. If we have a negative outside the bracket, like y equals minus x minus a all squared plus b, or written a different way, y equals b minus x minus a all squared, we'll have a maximum turning point. Everything else is still the same. The only thing that changes is your turning point becomes a maximum because that x squared becomes negative. So I'll still have a turning point at a, b, and axis of symmetry at x equals a. So same as before, the bit inside the bracket has the opposite sign. The y coordinate is the number outside the bracket. So sketching then, a turning point would be 2, 3, but this time it's going to be a maximum turning point at 2, 3. It's going to cut the y-axis when x equals 0. So when x equals 0, y is 3 minus 0 minus 2 all squared, which is 3 minus 0 minus 2 is minus 2, minus 2 squared is 4, which is 3 minus 4, which is minus 1. So I'm going to cross at the point 0, minus 1. So my turning point is 2, 3, that's going to be about there. It's going to cross the axis at 0, minus 1, so about there. So it's going to come up, turn, and back down. There's my x. That wee flick there shouldn't be at the end of my graph. That's just been a wee drag on the tablet there. Again, we need to mark in the important points. We need to mark in where it crosses the axis. We need to mark in our turning point. Another one, turning point this time, and again it's a maximum turning point. So our turning point is minus 3, 4. It's going to cross the axis when x is 0. When x is 0, y is 4 minus 0 plus 3, just subbing in that 0, which is 4 minus 9, which is minus 5. So I've got turning point, minus 3, 4. I'm going to turn somewhere up here. It's going to cross the axis down here. It's going to come up, turn, and down. You see I missed my turning point there completely. Makes no difference, I'm just going to ignore my dot. That's going to be the point minus 3, 4, and that will be the point minus 5. The other way around then, the way we're more likely to get asked is to write down the equation of the graph. Now we need to be looking at this graph and recognising that it is upside down. Because it's upside down, I need a minus outside my bracket. My x coordinate is minus 1, it goes inside the bracket as plus 1, plus 5. Okay, equation of the axis of symmetry, doesn't ask us here, but let's put it in anyway, is x equals minus 1. This one, again, it's a maximum turning point, so I need to remember that minus. It's plus 5, so it becomes x minus 5 all squared plus 4, and axis of symmetry would be x equals 5. Okay, I'm going to stop there and leave you to try some of these. As ever, get in touch if you have any problems.